All right. It is the return of the scuffed stream. I am sideways now because I remembered I want to try this where you turn the model sideways and then in OBS you actually transform the source to rotate it. Let's see. Let's see. Transform, rotate, counterclockwise. And then we go back to studio, hide everything. Definitely a lot less anti-aliasing that I can see, but wow, the model's huge. Kind of, it's supposed to be that narrow? I don't know. So huge. I'm gonna test, see how I like this in the VOD later. Okay, what next? Oh, the stream. I forgot to update the stream description to include the same thing I put last week about one sec. What is it called? The attribution to music because I'm listening to the same 12-hour thing. Let me just edit that video. Okay. The only thing I don't like about this whole rotating the model 90 degrees thing is I had to freehand it, so I can't really. I don't have it like before. I had a system where I would zoom it in to a certain point, and it would always be that exact point every time. But since I'm freehanding it now, it's gonna have to be a little different every time, and that's gonna bother me for a while. I want to listen to the stream for a second to see what the audio sounds like. See what other. Okay, yeah, the audio sounds fine. The only other thing I changed so far is the smoothing of the mouth when I speak. So it'll be slightly more resource intensive, but it should be slightly smoother. The way the mouth moves is fine. Oh wait, this is supposed to be. This one is supposed to be big. I just remembered. I don't remember how big. No, that looks fine. Okay, let's switch over to. Oh, the music is overpowering my voice. Oh, I don't see YouTube chat. Let me test to make sure they're both working. Yeah, they're both working. Yeah, that was the bot from last week who tried to sell me something. Yeah. So far so good. Let's make chat a bit bigger. The audio. Don't want to attach it to a dock, but it just keeps trying. Okay. So far, so good. Now, another thing that I realize between this stream and last week's is I can't read. So it turns out Lua does. Oh wait, let me see what that shows. It doesn't look like it's showing anything I don't want seen, so I'm fine with that. It's sideways. Okay, so it turns out Lua does provide binaries. I just can't read. So if you go to the download section, it was right down here. Are available as Lua binaries. You click this, takes you to SourceForge, and then you have executables, and there you go. Yeah. So I do want this one for Windows. Cool. I don't know what this is. I'm gonna delete it before I see it. Let's extract this. Let's just check real quick. If we do speed or can I do a version like this? No. Just run it. Okay, so it's 5.4.2. And if we SSH that's 5.4.7. Okay, so this one is a bit out of date, just a bit. But I'll still take it. Just because these ads are awful. Because I do want to use why did I close command prompt? I want it to use micro. Oh, I don't have a micro installed. Where's Chrome? I just closed Chrome. Maybe, no, not that one. I think it starts with a Z. Oh, wow, there's a lot. Yes, this one. Alright, now let's exit and open the terminal again. In PowerShell, but we're not going to stay in PowerShell. I'm just gonna... Okay, micro is working and transparency is working. So there's one more thing I need to set up before the environment. It's actually, I don't know if I have it. Oh, it is. So I have this little plugin right here, this pick link source that's not native to Windows. It's actually this tool. Well, this is it. This part, this function is native to Windows, but this tool makes it so it's in the context menu, so it's easy to do. So basically, what I want to do is I don't need the zip file anymore. Actually, yeah, I'll keep both. Let's go over to documents. Let's go from the Sonic stream. Guess I'll just put it. Yeah. F. Okay. I want this file added to my path, so that way I don't have to be in the folder to call it. But I don't. Hold on, I need to make sure I don't leak something real quick before I open this. Okay. Yeah. Oops. Wrong button. Okay, yeah, it's not leaking anything. I thought it might show a path to the other user on the account, on the computer. Yeah, so I just want to add, or no, I want to edit path, add a new entry, this folder. Now, I want to go up to the Lua. Let's just make a new folder. Lua. And it's these. I don't know if I need to. Well, let's find out. Actually, we can just test it real quick. Yeah, you do need the ELL. But I don't want to type Lua 54, Lua C54, W. I don't even know what this is. So I'll just take all of them. Oh, that's a good. I don't know if that works like that actually. If I do this, does this work? No, I got an error. The error says it's looking for 54.dll. Okay, so, but this one should work. Yeah, that worked. Okay. So basically, I'm just going to copy all these and pick link source and go to path and drop all of them as symbolic links. And then I want to rename this one Lua. If you've never seen a symbolic link before, basically like a shortcut, similar to a shortcut. And that this lua.exe is actually pointing to the folder that's up one folder, down into the Lua folder, down into the Lua folder. So it's a relative link to the bin. And this 54.exe. And that way I can go here, for example, and type Lua, and it did not work. Oh. Why didn't it work? Let me double check the path. Oh, I didn't save it. Yeah, okay, now I did not mean to change the display settings, but I do need to go there in a second. So if I do Lua, perfect, just like Linux. But now the display settings, I need to change system. I think it's support developers. Nope, I cannot. Oh, here it is. Windows Terminal. And then I want the default profile to be command prompt. Then in the command prompt profile, let's change the appearance to make it Cascadia code for the ligature. And opacity 70%. Okay, so let's type in, let's go to the desktop. Type in CMD. It's working. What is a ligature, by the way? It's when you type these two characters and it becomes an arrow instead of something like let's say notepad. Well, we can also do equals, greater than. It just makes the text look a little fancy. I like the way it looks. I think that's set up now. So we can go ahead and go to, what did I do in the Linux machine? Sample.lua and Lua c.out. Actually, I am curious about that. Let's see. Just do it here. And then we can, there isn't a touch command. Echo. Maybe this works? Sample.lua. Oh. Okay. I just want to try something simple. Oh, it's Lua C54 sample. And then we should be able to do Lua with c.out. Okay, that does work. I do need to change this symbolic link so I don't have to type 54. I don't know what WLUA is. And that book was this book, I believe. I'm so good at opening PDFs. Why won't it open? Oh. I don't remember which page I was on last time. But, turn the music up a bit. Oh, I just clicked the wrong button. Well, I get very big because I'm very blind. So 200? 200's fine. Every time the model jerks like that, it usually happens because I'm either drinking something or I'm scratching my face and the camera doesn't know. This is a regular Android phone, so I don't have any LiDAR. What page was I on? I was on 7 pages after 20, so. Just try to adjust the size of this a bit. And make chat visible. Is chat. I think I'm still signed into Twitch. I'm signed out of Twitch. Why am I signed out of Twitch? Oh no, I'm not. Okay. It's been 24 minutes. Maybe I'll start. Okay, so I remember that I was very shocked that you could do this. This printer, you can OR 2 different functions. I have since watched some Lua tutorials and I figured out why. It's because I'm actually a terrible person to explain this. But it was explained to me that the functions are not that different from regular variables. Where actually functions are a data type, and a variable holds any type of data. And so you can do things like a equals print. Oh, Lua. A equals print. And you can hello world. And it's the same thing as typing print Hello world. And that's pretty much why you can board, I believe. I could be wrong. Oh, speaking of wrong, never mind. I can't even explain it, so it doesn't really matter. Okay. Chunks. The unit of compilation of Lua is called a chunk. So I believe the latest. I could have sworn there was an aliases command. I guess not. Oh wait, I have an idea. I can just do this. And I can echo, what is it? Yeah, /b. And then do that to ls.bat. And now when I type ls, oh, thank goodness. Oh, micro, I set the top screen as the default display to get rid of the taskbar, but now everything opens up there. It's kind of tedious. Okay, micro ls. Let's try that. Cool. Not perfect, but it lets me stop having to type that so much. Okay. Sample. Okay, so I believe this is a chunk when you Lua C sample, and it creates that Lua C.out. The unit of compilation of Lua is called a chunk. A chunk can be stored in a file or in a string inside the host program. To execute a chunk, Lua first precompiles the chunk into instructions for a virtual machine. Oh wait, there's one more thing I meant to mention. It's really minor, but I'm using a different phone today, so if I become desynced again, I'm just going to reset the connection. I'm not going to use my old phone. I want to try to see if this works with this phone too. Okay, that was all. To execute a chunk, Lua first precompiles the chunk into instructions for a virtual machine, and then it executes the compiled code with an interpreter for the virtual machine. Chunks can also be precompiled into binary form bytecode using LuaC, the compilation program that comes with Lua, or the string.dump function, which returns a string containing a binary representation of the function it is given. Still confusing. The load function can be used to load a chunk. Is that? Oh, it is real. So that's not, you can't just, it doesn't assume that it's in the same place that you're currently at. The load, wait, can I do load? Print? No. Okay, just curious. Okay. The load function can be used to load a chunk. If the first parameter given to the load function is a string, the chunk is that string. In this case, the string may be either Lua code or Lua bytecode. If the first parameter is a function, load will call that function repeatedly to get the pieces of the chunk. What? Load will call that function repeatedly to get the pieces of the chunk, each piece being a string that will be concatenated with the previous strings. It is then considered that the chunk is complete when nothing or the empty string is returned. I don't really need to know how this works because I don't understand what I'm reading. The load function will return the compiled chunk as a function if there is no syntactic error. Otherwise, it will return nil and the error message. So what if I do, I don't know why I'm trying to figure this out. Print hello. No, that's not how that works. Yeah. The second parameter of the load function is used to set the source of the chunk. The second parameter. All chunks keep a copy of their source within them. In order to be able to give appropriate error messages and debugging information. By default, that copy of their source will be the code given to load. If code was given, if a function was given instead, it will be this string. This parameter can be used to change it. This is mostly useful when compiling code to prevent people from getting the original source back. It is necessary to remove the source included with the binary representation because otherwise the original code can be obtained there. I don't know why I'm reading this. The third parameter of the load function can be used to set the environment of The third parameter of the load function can be used to set the environment of the generated function, and the fourth parameter controls whether the chunk can be in text or binary. It may be the string B, only binary chunks, T, only text chunks, or BT, both binary and text. By default the default is BT. There is also a load file function which works exactly like load, but instead gets the code from a file. The first parameter is the name of the file from which to get the code. There is no parameter to modify the source stored in the binary representation. And the third and fourth parameter of the load function, there's no parameter to modify, so why would you say there is no parameter but then jump to the third and fourth parameter? How do you specify a second parameter that doesn't do anything? The third and fourth parameter of the load function correspond to the second and third of this function. The load file function can also be used to load code from the standard input, which will also be done if no file name is given. Now that is interesting. So, Load code from the standard load file. Load file. What was the name of that program? Lua. Okay. Load file. Lua c.out. Let's see if this works. No, it did not work. I don't think this is going to work. Yeah, I think I need an example for me to understand how to do this. But I do like this part. You can use standard input, which means you could technically use it to write tools like this. ls batch file I wrote just now, or put. Anyways, the dot file function is similar to the load file function, but instead of loading the code in a file as a function, it immediately executes the code contained in the source file as a Lua chunk. Okay, I'm going to try this without reading. Oh, do file. So, see that out. No. File, sample, .lua. No. What if I do... Okay, yeah, I'm gonna have to just wait for examples. It immediately executes the code contained in a source file as a Lua chunk. Its only parameter is used to specify the name of the file it should execute the contents of. If no argument is given, it will execute the contents of standard input. If the chunk returns values, they will be provided by the call to the dot file function, because the do file function. Because do file does not run in protected mode. Sorry. Sorry, I had to burp. Because do file does not run in protected mode, all arrows in chunks executed through it will propagate. Before I really want to try. Oh my goodness, I cannot type. I don't think this should work, but I'm gonna try it anyway. I'm just curious. Do file. No, that's not how that works. I cannot hear the music. I see it playing. It's so quiet. But if I turn it up, it's gonna get loud. Unexpectedly loud. Okay. I really am gonna need to see examples for do file, load file, and load functions. Push, pop. Okay. An illustration of a stack and of the operations that can be performed on it. So this is a stack, and I guess this is pushing something onto the stack, and this is popping something off of the stack. I wanted to click chat to make it appear in front of OBS. Okay. A stack is a list of items where items can be added, pushed, or removed, popped, that behaves on the last in, first out principle. So the last one in is also the first one out, rather than first one in, first one out. which means that the last item that was added will be the first to be removed. This is why such lists are called stacks. When a stack, you cannot remove an item without first removing the items that are on top of it. All operations therefore happen at the top of the stack. An item is above another if it was added after that item. It is below it if it was added before that item. A function, also called a subroutine, a procedure, a routine, or a subprogram, or a method, is a sequence of instructions that perform a specific task and that can be called from anywhere else in the program whenever that sequence of instructions should be executed. Functions can also receive values as input and return an output after potentially manipulating the input or executing a task based on the input. So functions can also receive values as input. So when I print hello, the print function is receiving hello as input and return an output after potentially manipulating the input or executing a task based on the input. So if I do 5 plus 5, this is an operator, but it's acting like a function, and it's returning the value of 10. Functions can be defined from anywhere in a program, including inside other functions. Okay, so this is what I meant before when I said I was wrong. I said some things about functions I didn't quite understand, and so I think functions in this language are more powerful than I anticipated. And they can also be called from any part of the program that has access to them. Functions, just like numbers, and strings, are values that can be therefore stored in variables and have all the properties that are common to variables. These characteristics make functions very useful. Because functions can be called from other functions, the Lua interpreter, the program that reads and executes Lua code, needs to be able to know what function called the function it is currently executing, so that when the function terminates, when there is no more code to execute, it can return to execution of the right function. This is done with a stack called the call stack. Each item in the call stack is a function that called the function that is directly above it in the stack until the last item in the stack, which is the function currently being executed. I read that wrong. This is done with a stack called a call stack. Each item in the call stack is a function that called the function that is directly above it in the stack until the last item in the stack, which is the function currently being executed. When a function terminates, the interpreter uses the stack's pop operation to remove the last function in the list, and then it returns to the previous function. There are two types of functions: built-in functions and user-defined functions. Built-in functions are functions provided with Lua and include functions such as the print function, which you may already know. Some can be accessed directly, like the print function, but others need to be accessed through a library, like the math.random function. Okay, so what if I do math.random? It needs arguments maybe 5. Okay, so it gives me a random number between, but what if I give it another argument? Okay, it only takes one argument. So if I do 10, random value between 1 and 10, it looks like. Cool. What happens if I give it a negative number? No, that doesn't work. There is no Control L to clear the screen. It's truly if only I could make this transparent through SSH. I don't know how to do that. Nano just works. I don't know. Okay. Whoops. I didn't want. I wanted to Lua. Okay. Through a library, such like the math.random function, which returns a random number. User-defined functions are functions defined by the user. Fascinating. User-defined functions are defined using a function constructor. Yeah, so there's two different ways to write this. You can write func equal function parameter 1, parameter 2, parameter 3, or what is the comment? Or you can write function, naming the type, and then naming it. So this is what I learned in one of the lectures that I mentioned I watched off stream, is that this is syntactic. What he said is this is syntactic sugar for this one, and that all functions are actually lambda functions or anonymous functions. And then here's where I'm assigning it a label, or I'm sorry, an identifier. I don't know if the book is going to say that, but that's what the lecturer said. Okay, so user-defined using a function constructor. Local funct equals anonymous function that takes on 1 parameter, 2 parameter, 3 parameters. And then the body, a function's body is the code it contains, and then the end. The code above creates a function with 3 parameters and stores it in the variable func named identified as func. Following code does exactly the same as the above code, but uses syntactic sugar for defining the function. So let's try one. No, not local. Let's just do func. Let's call it add 3. No. Yeah, add 3. Okay, function. First parameter. Oh, that's awful. E1, E2, E3. Actually, I want to see if I can do it with no spaces. And then you'll see the double line. That means I'm still inside of the function definition constructor or definition, whatever. And so I want to return P1 plus P2 plus P3. And then in. So now I can add 3. And then I should be able to put as much white space as I want between the arguments and the identifier of the function. Let's say 11, 11, 11. Cool. Add 3. Should be combine 3. Whatever. 3, 2, 7. So 12. Alright. The code above, I read that already. So function, this looks like C code. It should be noted that when using the second form, it is possible to refer to the function from inside itself, which is not possible when using the first form. Oh. This is because the local function foo end translates to local foo equals function Oh, so it creates an empty variable and then gives the variable a value that is a type function, rather than local foo equals function. And that means that foo is part of the function's environment in the second form and not the first, which explains why the second form makes it possible to refer to the function itself. In both cases, it is possible to omit the local keyword to store the function in a global variable, which is what I'm doing here in the interpreter. Because I had this issue when I'm off camera. If I do local 2 equals, I don't know, yeah, function, let's see if it happens here, p2, return p1 plus p2, and then end. If I go to add 2, it's nil. So I don't know how, once you declare it local, how do I call it in the, I wouldn't even know. But if I do the same thing, just return p1 plus p2, and then add 2, there is a function here. So there's probably a way to do this. I know if I write it in a text file, local wouldn't really matter. But when dealing with the interpreter the way I like to, that's why I'm omitting the word local. Okay, in both cases, it is possible to omit the local keyword to store the function in a global variable. Parameters work like variables. And allow functions to receive values. When a function is called, arguments may be given to it, like print receiving a string. The function will then receive them as parameters. Parameters are like local variables defined at the beginning of a function and will be assigned in order depending on the order of the arguments as they are given in the function call. If an argument is missing, the parameter will have the value nil. The function in the following example adds 2 numbers and prints the result. It would therefore print 5 when the code runs. That's pretty similar to what I did. But what happens? I am curious. Is there an add function? There is not. I guess you could just account for that. Okay, I'm gonna take a detour. So, not n. Print if. Oh wait. What if I do add 5? No, that doesn't work. Okay. Function add first number, second number. If can I was I taught how to use if statements yet? If second number is not equal to nil, print what was it? First number plus second number. Oh. Okay. Then print first number plus second number. I'm trying to make a contrived example to see what happens if I don't put in 2 arguments. So print first number plus second number. and then else. Right. First number, and then end, and end. Okay. So if we add 3, 3, and 3, we should get printed 6. And if I just do 3, it should just be 3. Okay, so that does work. So, okay, cool. Yeah, I just wanted to try. I don't know if I can. Oh, that works. I guess 3 plus nil would also be. Oh, no, that doesn't work. Oh, it's because nil specifically. Okay, yeah. I really wish I could clear that. Function calls are most of the time under the form name parentheses arguments. However, if there is only one argument and it is either a table or a string and it isn't a variable, I'm changing position. The camera's gonna mess up. Hopefully I don't get disconnected from the network. I'm gonna tilt the camera back a little. Okay. Function calls are most of the time under the form name parentheses arguments. However, if there is only one argument and it is either a table or a string and it isn't a variable, meaning it is constructed directly from in the function call, expressed as a literal, the parentheses can be omitted. So print hello world. Oh, you can print a table like that? What is that result? A data type known as table with this. I wonder. No. Well, maybe. TheRelaxedMovement. With a large value. I was just curious. Oh, wait a minute. The second line of code in the previous example would print the memory address. Okay, that explains it. The memory address of the table. And converting values to strings, which the print function does automatically. Complex types such as functions, tables, user data, and threads are changed to their memory address. Booleans, numbers, and nil values, however, will be converted to corresponding strings. Really? Oh. Okay, cool. Is it called type? Can you do type nil or type print? Well, why can't I do type? Was it OS dot? No, IO dot right. Okay. As much as I want to use... oh my goodness. Much as I want to use micro, this clearing the screen thing. Sorry, I have to burp. my water. Sorry for the camera, I'm about to drink some water. Okay. As I was saying, as much as I want to use micro in the transparent editor, I cannot get over having to exit Lua and then write CLS so often, so I'm going to go back to Linux. And that means nano. You do Lua, OS, okay. Oh my god, I missed pressing that so much. I need to figure out how to add that function to Windows. If it can be. Well, actually... Oh, I could just use, can I do this? No, it doesn't work still. Works in PowerShell, but it's not like a function of the terminal. Maybe it is. I just don't know how to do it in any case. Day at laptop. CD Lua. Where? Hey, it doesn't matter. I'm gonna. But yeah, it does matter. CD micro.bash RC. I think it's this one. Equals CLS. I think that's how it's done. Nope. Clear. Okay. Now let's... Oh my goodness, thank you. Thank you. That was such a pain. Okay, so now I have my control L, and I can type CLS instead of clear, and CD Lua. Okay. Let's get back to this. The second line of the previous example would print the memory address of the table. When converting values to strings, we read this already, or changed to their memory addresses, booleans will be converted to their corresponding strings. The terms parameters and arguments are often used interchangeably in practice. In this book, and in their proper meanings, the term parameter and arguments mean respectively the name and interchangeably in practice. In this book, and in their proper meanings, the term parameters and arguments mean, respectively, a name to which the value of the corresponding argument will be assigned, and the value that is passed to a function to be assigned to a parameter. I see. A name to which the value of the corresponding argument will be assigned. So the parameter is the name of the value of the corresponding argument, and the value that is passed to the function to be assigned. So parameter is pre-assignment and argument is pre-assignment, parameter is post-assignment. That's what it sounds like. Returning values. Functions can receive input, manipulate it, and give it back. You already know how they can receive input as parameters. No. 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 A value that is passed to a function to be assigned. The term parameters arguments respectively a name in which the corresponding. Shouldn't this be arguments? You don't receive the parameter, you label the value that is given to you. The input is the value that's given to you. I feel like that should be argument. Whatever. Functions can receive input, manipulate it, and give it back. And give, yes. You already know how they can receive input, parameters, or arguments, and manipulate it, the function body. They can also give output by returning one or many values of any type, which is done using the return statement. This is why function calls are both statements and expressions. They can be executed, but they can also be evaluated. Function add first name the parameter and second name the parameter. Return first name plus second name. End. Print add 5 and 6. It'll add 5, 6, you get 11, and then it prints 11. The code above will first define the function add. Then it will call it with 5 and 6's values. The function will add them and return the results, which will then be printed. This is why the code above would print 11. It is also possible for a function to return many values by separating the expression. What was that? There was something right here that just moved. It is possible for a function to return many values by separating the expressions that evaluate these values with commas. Errors. There are 3 types of errors: syntactic errors, static semantic errors, and semantic errors. Syntactic errors happen when the code is plainly invalid. So there is no printf. Oh, there is no printf below %d 27. I think that's a syntactic error. Maybe not. Sorry. Syntactic errors happen when the code is plainly invalid. The following code, for example, would be detected by Lua as invalid. The code above doesn't make sense. It is impossible to get the meaning out of it. Similarly, in English, cat, dog, tree is not syntactically valid because it has no meaning. Doesn't it though? It doesn't follow the rules for creating a sentence. Static semantic errors happen when code has a meaning but still doesn't make sense. For example, if you try adding a string with a number, you get a static semantic error because it is impossible to add a string with a number. Not true. It's just not. I mean, there are multiple ways you can interpret this. Why am I fighting with the book? Why? Well, I'm not. Why? The code above follows Lua's syntactic rules, but it still doesn't make sense because it is impossible. What I was going to say is you convert each character to an ASCII. Well, I guess you wouldn't know if you add 5 to the total or to each individual. It's not a multiplication, so you wouldn't do it to... Okay, anyways. The code above follows Lua's syntactic rules, but it doesn't make sense because it is impossible to add a string with a number, except when the string represents a number, in which case it will be coerced into one. Coerce. The word I was looking for last time was typecasting. That's what I've heard it called before. This can be compared in English to the sentence, I are big. I mean, this means I am big. It's just, it follows the rules for creating sentences in English, but it still doesn't make sense because I is singular and are is plural. I guess. But the thing about English is it's To convey. Why am I fighting with the book? Stop fighting with the book. Finally, semantic errors are errors that happen when the meaning of a piece of code is not what its creator thinks it is. Those are the worst errors because they can be very hard to find. Lua will always tell you when there is a syntactic error or a static semantic error. This is called throwing an error. But it cannot tell you when there is a semantic error since it doesn't know what you think the meaning of the code is. These errors happen more often than most people would think they do, and finding and correcting them is something many programmers spend a lot of time doing. The process of finding errors and correcting them is called debugging. Most of the time, programmers will spend more time finding errors than actually correcting them. This is true for all types of errors. Once you know what the problem is, it is usually simple to fix it. But sometimes a programmer can look at a piece of code for hours without finding what is wrong with it. Interesting. Throwing an error is an action of indicating whether it is done manually or automatically by the interpreter, the program that reads the code and executes it. That something is wrong with the code. It is done automatically by Lua when the code given is invalid, but it can be done manually with the error function. Local variable equals 500. If variable modulus 5 is not equal to 0, what is 500 modulus 5? It is equal to 0. Some noise outside my room. Error. It must be possible to divide the value of the variable by 5 without obtaining a decimal number. What? The error function so it says if 500 modulus 5 is not equal to 0, so it is equal to 0, so then this wouldn't run. Oh, let me try this. I think I understand. Variable 100. Okay. Whoops. As if variable percent. Let me put this in a function. What is it? Check equals function. What was the code? What was the code? I think it was asking if I have arguments. Let's say check var function. I don't have any arguments. I just wanted to execute this code. Okay. So if variable %5 is not equal to 0, then error. It must be possible to divide the value of 5 without changing the decimal number. Oh. Then end. Why am I guess. Okay, so let's check. What is it called? Check var. Oh my god. Um, okay. We'll do this the hard way because I'm curious. Okay, Lua sample. Unfinished string near Y. I don't know. I'll have to check that later. Or right now, I guess. Okay. The error function also has a second argument, which indicates the stack level at which the error should be thrown. This will not be covered in this book. The assert function does the same thing as the error function, but it will only throw an error if its first argument evaluates to nil or false, and it doesn't have an argument that can be used to specify the stack level at which the error should be thrown. The assert function. The assert function is useful at the start of a script, for example, to check if a library that is required for the script to work is available. Oh, I have the hiccups now. It may be hard to understand why one would desire to voluntarily throw an error, since the error in a program stops running whenever the error is thrown. But often, throwing errors when the functions are used incorrectly or when the program is not running in the right environment can be helpful to help the person who will have to debug the code to find it immediately without having to stare at the code for a long time without realizing what is wrong. So I need to learn more about Lua's error error and assert functions. Remind myself to look that up later because I feel like the book is not going to give me a clear enough idea. Sometimes it is useful to prevent an error from stopping the code and instead do something like displaying an error message to the user so he can report the bug to the developer. This is called exception handling or error handling and is done by catching the error to prevent its propagation and running an exception handler to handle it. The way it is done in different programming languages varies a lot. In Lua, it is done using protected calls. They are called protected calls because a function called in protected mode will not stop the program if an error happens. There are two functions that can be used to call a function in protected mode: pcall and xpcall. Okay. Calls the function in protected mode and returns a status code, a boolean value whose value depends on if an error was thrown or not, and the value returned by the function. Wait a minute. That sounds familiar. What is it? %0? No, that's not it. I think it's Windows. if I say hi and then print. Oh, that didn't work. Keep wanting to type admin laptop. CD Lua. Okay, yeah, that sounded similar to what the error level, at least what I think, the error level. Um, and the values returned by the function, or the error message if the function was stopped by an error. Arguments, wait. A boolean whose value depends on if an error was thrown or not, and the values returned by the function, or the error message if the function was stopped by an error. Arguments can be given to the function by passing them to the pcall function after the first argument, which is the function that should be called in protected mode. Definitely going to need to do some research on this. xpcall does the same thing as pcall, but when the function errors, instead of returning the same value as those pcall would, it calls the handler function to help them as parameters. The handler function can then be used, for example, to display an error message. As for the pcall function, arguments can be passed to the function by being given to the xpcall function. This is way going right over my head, and I'm not even going to pretend like I know. Hopefully, I won't have to use it anytime soon. Stack Overflow. The call stack, the stack that contains all the functions that were called in the order in which they were called, was mentioned earlier. That call stack in most languages, including Lua, has a maximum size. This maximum size is so big that it should not be worried about in most cases. But functions that call themselves, this is called recursivity, not recursivity. Recursivity, and such functions are called recursive functions, can reach the limit if there is nothing to prevent them from calling themselves over and over indefinitely. This is called a stack overflow once they reach the maximum. When the stack overflows, the code stops running and an error is thrown. I wonder why there's a big website called Stack Overflow. Maybe it has something to do with that. Maybe it's like a famous bug or something. Variadic functions. What? I've never heard of this before. Variadic functions, which are also called variable arguments functions, are functions that accept a variable number of arguments. Vararg? That's such an ugly name. A variadic function is indicated by the 3 dots at the end of the parameter list. Oh, I thought it was only 3 dots, but I didn't know it could be at the end of the list. So that means you can have mandatory amount of parameters and then a variable amount after that. Arguments that do not fit in the parameters in the parameter list, instead of being discarded, are then made available to functions through vararg expressions, which is also indicated by 3 dots. The value of vararg, how do you say this? Varargs. Okay, just once for the stream because
Vargs. Vargs. Vargs.
If the voice line changed when I open it in this browser versus the other browser. Whatever. Oh my god, that's it's not a word I enjoy. Definitely not one of my favorites. Putting everything back up. The stream's been going for an hour and 28 minutes. No dropped frames. That's pretty good. Okay. The value of the varargs expression is a list of values, not a table. Hold on. Was that where I was? Arguments that do not fit in the parameters list, instead of being discarded, will be made available to the function through a vararg expression, which is also indicated by 3 dots. The value of the vararg expression is a list of values, not a table, which can then be put in a table to be manipulated with more ease with the following expressions. In Lua 5.0, instead of being available through a vararg expression, the extra arguments were available in a special parameter called arg. The following function, special parameter. The following function is an example of a function that would add the first argument to all the arguments it receives, then add all of them together and print the result. What did you just say? Okay. Add one, increment. So it increments whatever you pass in, I'm guessing. So it takes one parameter named increment and then a variable number of parameters. Local result equals 0. Or what is this? In numbers? Or match? I've seen this before, but not in this book. Number in next the table of, oh my god, this is so confusing to read out loud. I think it's saying for each value that is a number in, and then next here, this I think is basically cycling. I'm guessing here. I think it's cycling through the variable number of arguments and it's putting them into a table. Do the following code. Result is equal to result plus whatever number plus the increment. It is not necessary to understand the code above. It is only a demonstration of the variadic function. That is, oh my goodness, that's hard. The select function is useful to manipulate arguments list without needing to use tables. It is itself a variadic function, as it accepts an indefinite number of arguments. It returns all arguments after the argument with the number was given as its first argument. If the number given is negative, it indexes starting from the end, meaning -1 is the last argument. It will also return the number of arguments it received, excluding the first one. What? If the first argument is the string, the pound sign, or the operator for string.length, or array.length, the length, whatever. It can be useful to discard all arguments in an argument list before a certain number, and more originally, to distinguish between nil values being sent as arguments and nothing being sent as an argument. Indeed, select will distinguish. This is a mouthful. It's really one of the. This one and the last paragraph were very difficult for me to comprehend. Indeed, select will distinguish when hash is given as its first argument, nil values from no value. Argument lists and return lists as well are instances of tuples, which will be explored in the chapter about tables. The select function works with all tuples. Holy moly. Print. Oh my god, what am I looking at? Print is a function that takes a variable number of arguments and returns select. What in the world am I looking at? I don't think I'm smart enough. As the code shows, the function of. Okay, wait. What is the difference between at least the first one and the second one? No. The variable is not defined. As this code shows, the function is able to detect whether the value nil was passed as an argument or whether there was an empty. There was simply no value passed. Okay, might as well try it, even if I don't understand it. Oops. No, I don't really get it. I mean, I understand the basics. I think the basics are saying that the select function will differentiate between explicit nil or no argument or, and what was the last one? Variables that is not defined. In normal circumstances, both are considered as nil, and this is the only way to distinguish them. Well, I may have to, you know what? I will add that one to the list. Micro notes. I'll look that one up more. The standard libraries. Lua is a language that is said to not be. Lua is a language that is said to not be provided with batteries. What in the world does that mean? This means that its libraries are kept to a minimum necessary to do some stuff. Lua relies on its community to create libraries that can be used to perform more specific tasks. There are 10 libraries available in Lua. The Lua reference manual provides documentation for all the libraries, so they will only be briefly described here. All the libraries except the basic and the package libraries provided their functions. Wait, what? All the libraries except the basic and the package libraries provide their functions and values as fields of a table. So I'm gonna read ahead first quick. I just want to make sure. No. Okay, so 5.2 is coroutines. So I just want to check real quick. I just want to see if I can get a list of all 10 standard libraries, the names of them, the reference manual. Oh, here it is. Oh, coroutines is one of them. Okay. Oh wow, this is huge. Okay. So those 10, I believe, I'll watch me read it in the book right after. It looks like it is basic, coroutines, modules, string manipulation, UTF, table manipulation, mathematical functions, IO, OS, debug, Patterns and format strings. I am kind of interested in operating system and I/O. I use it to make basic tools, very, very basic tools. The basic library provides core functionality to Lua. All its functions. Wait, was I finished reading? Okay. Yeah. All its functions and values are directly available in the global environment, and all functions and variables directly in the global environment. And all functions and variables directly in the global environment by default are part of the basic library. Assertion. Well, that was one of the ones I didn't understand. An assertion is a predicate that is assumed by the developer to be true. They are used in programs to ensure that a specific condition is true at a specific moment of the execution of the program. Assertions are used in unit tests to verify that a program works correctly, but are also used in program code, in which case the program will fail when an assertion is false. I think it should saying would otherwise fail, or else it doesn't do anything if whatever. An assertion is false, either to verify that the environment in which the program is correct, or to verify that no error was made in the program code, and to generate appropriate error messages to make it easier to find bugs in the code when something doesn't happen as expected. Let me make sure that is in cat notes. Yeah, assert. I need to really look more into assertions, error, and the select functions, because they are all very confusing to me right now. In Lua, assertions are made with the assert function, which accepts. Oh, yeah, checking the tracking. Which accepts a condition and a message, which will default to assertion failed as parameters. When the condition evaluates to false, assert throws an error with the message. When it evaluates true, assert returns all its arguments. So what happens if I do something like assert the number 5? Doesn't do anything. Can I assert a string? Hello? You can assert a string. It's not expecting that. What happens if I... Oh, you need parentheses because... Yeah. Okay, yeah. So when it evaluates the true, the assert returns all of its arguments. Can I assert b plus 3? You can. Okay. Garbage collection. Garbage collection is a form of automatic memory management implemented by Lua and many other languages. When a program needs to store data in a variable, it asks the operating system to allocate space in the computer's RAM to store the variable's value. Then, when it doesn't need the space anymore, generally because the variable fell out of scope, it tells the operating system to deallocate the space so that another program may use it. In Lua, the actual process is much more complex, and the basic idea is the same. The program must tell the operating system when it doesn't need a variable's value anymore. In low-level languages, allocation is handled by the language, but deallocation is not, because the language cannot know when a programmer doesn't need a value anymore. Even if a variable that referenced a value fell out of scope or was removed, another variable or a field in a script may still reference it, and deallocating it would cause problems. In higher level languages, deallocation may be handled by various automatic memory management systems such as garbage collection, which is the system used by Lua. The garbage collector regularly searches through all the values allocated by Lua for values that are not referenced anywhere. It will collect values that the program cannot access anymore. Getting some water. I'm going to start here once I drink. Oh my god, I cannot highlight. Okay. Camera really doesn't like when I drink water. It will collect values that the program cannot access anymore because there is no reference to them. And since it knows that these values can safely be deallocated, it will deallocate them. This is done transparently and automatically, so the programmer does not generally need to do anything about it. However, sometimes the developer may want to give instructions to the garbage collector. Weak references are references that are ignored by the garbage collector. These references are indicated to the garbage collector by the developer using the mode meta method. Why do I have to burp so much today? A table's mode meta method should be a string. If that string contains the letter K, all the keys of the table's field are weak. And if it contains the letter V, all the values of the table's fields are weak. What am I reading? A table's mode meta method should be a string. If that string, I really wish it had an example of what I'm even supposed to see. When an array of objects has weak values, the garbage collector will collect these objects even if they are referenced in the array, as long as they are only referenced in that array and in other weak references. This behavior is sometimes useful but rarely used. Manipulating the garbage collector. The garbage collector may be manipulated with the collect garbage function, which is part of the basic library and serves as an interface to the garbage collector. Its first argument is a string that indicates to the garbage collector what action should be performed. A second argument is used by some actions. The collect garbage function can be used to stop the garbage collector, manually perform collection cycles, and count the memory used by Lua. Oh, I wish I want to know that one. Coroutines. Coroutines are computer program components that generalize subroutines to allow multiple entry points for suspending and resuming execution at certain locations. Coroutines are well suited for implementing more familiar program components such as cooperative tasks, exceptions, event loops, iterators, infinite lists, and pipes. Wow, that's a lot of references. Coroutines are components that can be created and manipulated with the coroutine library in Lua, and that allow the yielding and resuming of execution. You mean suspending and resuming? The yielding and resuming of the execution of a function at specific locations by calling functions that yield the coroutine from inside of itself, or that resume it from outside of itself. What did you just say to me? For example, a function in the main thread creates a coroutine from a function with coroutine.create and resumes it with coroutine.resume, to which the number 3 is passed. The function in the coroutine executes and gets the number passed to coroutine.resume as an argument. Nope, I'm already lost. It says, a function in the main thread creates a coroutine from a function. How? An example would be nice. With the coroutine.create and resumes it with the coroutine.resume. function in the coroutine executes and gets the number passed to a coroutine dot resume as an argument. The function arrives at a certain point in its execution where it calls coroutine dot yield as an argument. The sum of the argument it received 3 and 2, hence 3 plus 2 equals 5. I do not understand what I'm reading. The call to coroutine.resume returns 5 because it was passed to coroutine.yield, and the main thread, now running again, stores the number in a variable. It resumes to coroutine again after having executed some code, passing the coroutine.resume the double of the value it has received from the call to coroutine.I am so lost. I think I'm going to skip this. Coroutine create local code equals coroutine.create function initial. So this one, this was going to be more complicated than I anticipated. This one is not one I'm going to look up with my notes, because the notes I want to supplement the learning of this book. But for coroutines, there's so much I don't know. So I'm probably going to wait till another book. In addition, I'm going to look for some lectures on the topic, just because this is quite verbose. I don't think this is a good starting point, because I mean, I could read it anyway and see if it gets any better. The coroutine coroutine.create function creates a coroutine from a function. Coroutines are values of type thread. Coroutine.resume starts or continues the execution of a coroutine. A coroutine is said to be dead when it has encountered an error or has nothing left to run, in which case it has terminated its execution. When a coroutine is dead, it cannot be resumed. The coroutine.resume function will return true if execution of the coroutine was successful, along with all values returned. If the coroutine has terminated or passed to coroutine.yield, if it has not. The execution was not successful, it will return false along with the error message. Coroutine.resume returns the running coroutine and true when that coroutine is the main thread, or false otherwise. No, I don't understand. There are many uses for coroutines, but describing them are outside the scope of this book. So yes, I'll wait for another book. I don't think I'll revisit this one when I finally wrap my head around it though. We'll see. String matching. When manipulating strings, it is frequently useful to be able to search strings for substrings that follow a certain pattern. Lua has a string manipulation library that offers functions for doing this and a notation for expressing patterns that the functions can search for in strings. The notation offered by Lua is very similar to regex, regular expressions, a notation for expressing patterns used by most languages and tools in the programming world. However, it is more limited and has slightly different syntax. So many burps today. Excuse me. The find function of the string library looks for the first match of a pattern in a string. Hold on. I want to change position again. The find function of the string library looks for the first match of a pattern in a string. If it finds an occurrence of the pattern in the string, it returns the indices in the string, integers representing the position of the character in the string, starting at the first character, which is at position of 1. Wow, that's a complicated way of saying that. Strings are treated as like arrays. So if I have like the string hello, then position 1 would be H, 2 would equal E. Let's see if I can do this in Lua. I don't know if I can actually. Maybe A equals then A1? Oh no, it doesn't work like that. That's how it works in C. Because in C, a string is just an array of characters, but not in this. Oops. Okay. The only thing I'm worried about this part is slightly different syntax, because I don't know regular expressions, let alone, I've only used it once, and it was a long time ago. So, if you use the find function on a string, can I do find? I'm just guessing, I haven't even read it. Let's say 2, hello? Nope. Find, hello? 2? Oh wait. Okay, yeah, no. I will continue reading. So, the find function in the string oh wait. Why? Okay, just read. Just read. The find function of the string library looks for the first match of a pattern in a string. If it finds an occurrence of the pattern in the string, it returns the indices in which the string where the occurrence starts and ends. So if I have A equals, this is a long sentence. I do A dot find long? No. Maybe I should learn how to use the syntax. Integers representing the position of the character in the string starting from the first character, which is at position 1. Where the occurrence, okay. If it doesn't find an occurrence of the pattern, it returns nothing. The first parameter it accepts is a string, the second being the pattern, the third being an integer indicating the character position where the find should start searching. Finally, the find function can be told to perform a simple match without patterns by being given the value true as its fourth argument. Okay, so I'm expecting find sentence or string, character to match, characters to match, and then the third argument will be 0 if the fourth argument is true. I'm guessing. It will then simply search for the occurrence of the second string it is given in the first string. The third argument must be given when a simple match is performed. This example code searches for the word lazy in the sentence and prints the start and end positions of the occurrence. It finds of the word. Oh yeah, I said well, sorry, I'm talking loud now. I said 0 before, but I forgot the language is based on index of 1, so 1 would be the first. So it's string.find start position, end position. Wait, what? Start and equal 1, 2. Oh, no. Start ends. So that means string.find returns 2 values? Yes, it said that already. It said it returns the indices, 2 indices, where the occurrence starts and where it ends. So if I don't use these 2, I should still be able to do string.find and then something, I don't know, string.find. This is a short sentence, for example, and then I want to look for the word or, started 1, and I think that's it. Oh, there's a delay because I'm on the network. 13. Interesting. This. What is this? And if I do true, and if I go to string.find, this is a short sentence, for example. I'm just curious if I omit third argument. Oh, okay, so the third argument is optional. The second argument is not optional. The third and fourth are. But if you have a fourth argument, then the third one is not optional. A simple match without patterns by being given the value true. Uh, whatever. So, local start position. So, that's interesting though. It gave them to me as these, what only looks like tab separated values. I'm gonna try. A, B equals. Oh, Lua. A, B equals. What is A? What is B? No, it doesn't work like that. Yeah, I don't know why this was the representation instead of a comma. I was expecting 13 comma 14. Okay, so start position, end position. A string dot find this sentence, searching for the word lazy. It's starting at indices 1, and it is true for a simple match. Now let me read again the fourth argument, the fourth parameter. Finally, the find function can be told to perform a simple match without patterns by being given a true value as its fourth argument. It will then simply search for an occurrence of the second string it is given in the first string. Third argument must be given when a simple match is performed. Okay. So it is going to look for the word lazy in the sentence, and it'll find the first, the index where it starts and where it ends, and it'll store those values in the start position variable and the end position variable. And from there, we are printing the word lazy, it is escaping it instead of just using single quotes or the bracket things, was found starting at position and then it'll append or concatenate this string with this string, which is start position, and concatenate it with and ending at position the following. And the result will be a sentence that says, the word lazy was found at the starting position 36 and ending at position 39. It is equivalent to the following. Now, technically, you could do this. You could say, I don't know why, but I just want to see if it's possible. Okay. Okay. My goodness, I forgot how to exit. Okay, well, I'm on Windows, that's why. Um, so technically, you could do start position end position equals string. I'm just gonna copy this actually. Okay. Oh. Okay. I want to test start position end position equals string. Oh no. Start position. No, I don't really need start position. Is there a way to use the find function and not? Oh, no, the okay. So basically, what I was getting at was if you have the start position and you have the keyword, you can derive the end position by doing uh, lazy like that, and so you could do start position. In this case, would be 36. 36 plus lazy. Oh. Oh no, it's 40. I guess it would be lazy minus 1. That's uglier than I thought it would be. Okay, never mind. Let's not do that. In any case, local sentence. The quick brown fox jumps over the lazy dog. Start position, in position, sentence, fine, colon. What is this colon? That wasn't in the last one. It was string dot fine, sentence dot fine. Oh. So that's a syntactic sugar? Oh wow, it skipped the... Oh, I see now. So when you do it this way, you can skip entering the sentence as the first argument. You don't have to do sentence dot... actually, does that even work? Lazy. No, maybe lazy. Okay, what if I do... Okay. Okay, no, I don't know. SSH. Okay, I have a laptop. CD Lua. Alice. I've been known to accidentally delete things, so I'm not gonna I'm gonna have a copy outside the folder. It is equivalent to the following. Sentence equals this. Start position, in position, sentence, colon, find. And then you enter the key to search by. Then 1 and true, those are still the same. And then you're printing the word escaped, lazy, was found, at position, start position, and ending at end position. This works because the index meta method of strings is set to the table containing what? This works because the index meta method of strings is set to the table containing the functions of the string library, making it possible to replace string.a, b. Oh, I see. So it's a string.a where the a function has b argument with a variable number of arguments following that. You replace it with b, which is the argument of a function with variable arguments. That's interesting. Functions in the string library that accept indices to indicate character position, or that return such indices consider the first character as beginning at position 1. They accept negative numbers and interpret them as indexing backwards from the end of the string, with the last character being at position -1. Patterns are strings that follow a certain notation to indicate a pattern that a string may match or not. For this purpose, patterns contain character classes, combinations that represent... Oh my god, what am I reading? For this purpose, patterns contain character classes, combinations that represent sets of characters. So the dot is all characters, %A is letters, upper and lowercase, so alphabetic. C is control characters, I'm not sure what those are. D is digits or decimal. G is printable characters, except the space character. I don't know what this set means. L is lowercase letters, that's cool. P is punctuation characters. So printable characters, probably punctuation plus letters plus numbers. I'm guessing space is space characters. %U, I'm surprised it's not an uppercase, is uppercase letters. W is alphanumeric characters, digits and letters. And 0 or %X is hexadecimal. All characters that are not special represent themselves, and special characters, all characters that are not alphanumeric, can be escaped by being prefixed with a %sign. Character classes can be combined to create bigger character classes by being put in a set. Sets are noted as character classes noted between square brackets. For example, %XP will be the combination of %X and %P, so it should look for a hexadecimal and punctuation. Is a set of all hexadecimal characters put plus the letter P. Oh, so that's not what I thought it was. Characters plus the letter P. Ranges of characters can be noted by separating the end characters of the range in ascending order with a hyphen. So from 0 to 9, %S represents, I'm guessing, any value between 0 and 9 that has a space immediately following it. Is a set of all represents all digits from 0 to 9 plus space character. If the caret character is put at the start of the set, right after the opening square bracket, the set will contain all characters except those it would have contained if the caret had not been put at the start of the set. What does that mean? I may need to research this. The complement of all classes represented by the complement of all classes represented by a letter preceding of a percentage sign can be noted as a percentage sign followed by the corresponding uppercase letters. So percent capital S represents all characters except space. Oh, okay, okay. So if I were to do percent capital U, then that would be all non-uppercase characters. Represents all characters except the space character. Patterns, so it's like saying not this. Instead of look for this, look for this, look for this, it's like saying look for everything except this, except that when you use uppercase. Patterns are sequences. Actually, uh, I am no longer fresh and I've been at it for 2 hours, so I'm gonna actually finish the pattern thing next stream. I don't know if it's gonna be Tuesday again, because I thought I thought doing Tuesday streams would be like Sunday streams, but oh my goodness. To make a long story short, my this when I plan for things to happen, it's like Murphy's Law happens, and then things go wrong. And so I thought today would be a quiet time, but my neighbors has been very loud, and I don't wanna. I don't feel like. I don't want to feel like I have to stream on the same day if somebody is currently being very loud, and it makes it hard to read and concentrate. So because of that, I'm still not set on a specific day. And as for the Sunday streams, I right now I'm thinking I'm not going to continue doing dedicated Sunday streams after I finish uh, Mark of the Ninja. It'll I'll probably go back to being random because I cannot pin down a day right now. And I mean Sunday is still my least eventful day, but it's like uh, sometimes things come up, and I'd rather be more flexible right now. Do I have any other updates that I want to say? No, not that I can think of. This is my first 2 hour Lua stream. Mm. Oh, page 40. I do have two other books in mind, two other Lua books. I might do one of them on stream because it's shorter than this one, but the other one is longer than this one, so I might do that off stream or only do like specific parts of it. I know if the last day I do this book, it ends up being a short stream, then I'll definitely just open that one and look for some of these things that I have confused on, like the air and assert functions and the select, and might as well. Um, what is it? Regex. Yeah, so I don't know what I'm gonna do about. Oh, I forgot I'm on the different scene in OBS. You couldn't even see what I was typing right now. Uh, let's see. Well, yeah, I will continue this next time. I don't know if actually no. I'm just going to say right now it's not going to be guaranteed for Tuesday because that way I can leave the door open to just stream at a random time. Okay, enough stalling. That was the end of today's stream. See you next time.